Now, what would a new unit be without Hardy having an issue of some sort right off the bat? And I see it already. I noticed, bless you, I did a good job with the practice on numbering pages, and it looks like I forgot to number the note pages. So, let's take a moment here with the notes. Yeah, sure, why not? We're just starting a new unit. Why would we want to be seeing that? But make yourself... Did you make a pass? That's one nice thing with notes. Luckily, it's not like it's 5, it's front and back. It's only going to be 5 numbers here, so it shouldn't be too bad to be able to deal with. So, as we get into Unit 4, the main portion of this is going to be the forms that equations can take when we go to graph them. How can we move between them depending on what we're trying to do? And also trying to get set to be able to actually do some real-life applications with things. Some of which we'll use the calculator quite frequently, some of which we'll just kind of do our thing and see which way we like best. Because I always like to give people options, give them more tools in the toolbox. So for today, we are going to lock in on this first page of the notes and the forms that equations can take on and what parts we need to understand with them as we take a peek at these. So, oofda, 3 forms. Okay. Point slope form. Ooh, that seems kind of interesting. This is basically if we're given a point and a slope, how we can start to make an equation. But here's what I want you to take note of. When we're looking at point slope form, those are the 3 places that we're going to be plugging in numbers. So when I use point slope form, that x and that y never will change. They're always going to be x and y. But every other place here will turn into a number of sort before we start messing with it a bit. So that's why we want to put the arrows there, just so we remind ourselves, hey, when I'm plugging in, it's those 3 spots. When I look at the next one, okay, slope-intercept form. We've seen y equals mx plus b before. With those, the m, our slope, we'll even give ourselves a reminder here. We'll do this a lot in these notes. That's one thing, again, with the notes, too. I know everything isn't always solving a problem, but these little side notes that we do can be things that can really help out when you're kind of stumped in the middle of a quiz or the middle of a problem. So, slope, and then our y on the y-axis, intercept with those. Standard form we're not really going to talk about today, but I'll mention it just in passing right now. This is when we put the x and the y on the same side. That's all this is saying. A and B is just a number. A, the number in front of x must be positive and a whole number. So no fractions when we're dealing with standard form. And so like I said, we're going to take these basically one at a time, and then we're going to start seeing how they all come together and relate to each other as we work through these. So, this first part we're going to look at is going to be kind of a review of some stuff we just got done doing. So, graph the line that goes through the point, -1, 2, and slope 3. Okay, before we start, let's get our x and our y-axis labeled so we remember where we're going here. Remember, any coordinate point you ever have is x and y. Now, that doesn't mean that I'm going to go to -1 and put a point, then I'm going to go to 2 and put a point. This is one point. So I go left to where x is -1, and I go up to where y is 2. There's my first point. Okay? So graph the point. Check. We did that. From the point, okay, don't start back over. Use slope to graph more points. If you have slope and it's not a fraction. Okay? Slope always needs to be a fraction. If it's one naturally, great. If it's not, we've got to put it over 1, because when we do rise over run, if it's positive, we're going to be going up. And, whoops, excuse me, that was kind of sudden. If my run is positive, we're going to go right. So you can kind of tell again, if it's negative, it'll be down or left, but we'll get into some of those too. So I start here, I go up 3, right 1, and I put another dot. Now, to be honest, I could draw my line through there right now. That'd be fine. But if I wanted that third point, if I wanted to be sure I was doing it right, I could go back to my original dot and do the opposite of both of these. So I could go down 3 and left 1 and make a third dot if I wanted to. Now, do you have to make a third dot? No. That is not a necessity. It just lets us make sure, feel hopefully, that we're doing it correct. So that's the graphing portion. But then if I wanted to make an equation out of this that someone else could look at later and say, hey, how do you graph that? We can do this. So here's what we're going to do. Okay, write the equation in point slope forms. We got point slope right here. Plug in x1, y1, and the slope. So when we were doing these were actually x1 and y1. Or I could actually just put them here. That's probably a good idea too. Let's do that. And my slope, 3. Alrighty, why aren't you putting 3 over 1? I'll explain in a minute. We'll put the 3 for now. And I'm literally just going to go now. I'm going to follow this point slope form. And like we said before, y stays the same. Minus, there's my y1. So y minus 2 equals m, another fancy way of saying slope. And just keep copying. X minus -1. Oh, I thought things were going away. I was scared. Now you're like, okay, wait a minute, Hardy. That's a whole lot of parentheses and negatives and all sorts of weird stuff going on. So what exactly did you just do? Okay. So once we plugged in my y1 and my m and my x1, everything else was just exactly copying from this. Here's the one thing I would make mention of right away. What happens if you minus a negative? Okay, this becomes plus. It's almost like the minus and the negative cross over and make a plus sign, if I wanted to say it that way. So when I get here, okay, this, I'm just going to rewrite it. I don't like seeing that plus there. That drives me crazy. Okay, so if I was asked just to put something in point slope form, that right there is in point slope form. If that's all you're asked to do, you'd be done. Okay? However, here's where we're going to make our first connection. We're used to graphing lines when they're in slope-intercept, when they're in y equals mx plus b. So now it says write the equation in slope-intercept form. You're like, what the heck? Now what do I do? So now I'm going to distribute the 3 next. So I'm going to change colors here as we keep going here. So I'm going to distribute, I'm going to multiply the 3 to each of these. Make sure it's to both. And I start to look and I'm like, okay, slope-intercept form. Y is by itself, and then mx plus b. Well, y has to be by itself. It's not quite there yet. So to get y alone, I got to add 2, but I'm not going to add the 2 to just any old place. You've got to add the 2 to the other plain old number because we can only combine terms that are alike. And that is slope-intercept form. So we had point slope form here. Now we've taken, it's the same equation, we've just moved things around. And now it's slope-intercept. So let me take a moment to let us see, now that we've done that, my y-intercept, my b is at 5. So was the point that I plotted there. My slope is 3, or 3 over 1. Well, I can't go, but if I go anywhere here even, 1, 2, 3, 1. 1, 2, 3, 1. So I've made this equation just from having the point in the slope. So it gives me some more flexibility. But again, keeping my forms straight and how to go between them is going to be nice. This is going to be a real nice first sheet of our notes because we have one last form left that we need to get this into, and that's standard form. So let's come back down for just a minute here. So x and y have to be on the same side, but the number in front of x has to be positive. So you're like, okay, so let's see here. So if I keep going, my first job is x and y have to be on the left side. Okay, let's keep it rolling. I'm just going to rewrite this for a minute. Okay, first job. Y is already over on the left side. X needs to come over. So the opposite of positive 3x would be minus 3x. And again, this has x, this has y. Those are not the same thing. So they stay separate. You're like, so I'm done. So x and y are on the same side. This is good. Okay, but one last thing to check. The x term must be positive. Uh-oh. It's not positive. Well, but if I add it back to the other side, now it's not going to be on the left side anymore. What the heck? If it's negative and we have to fix it, one quick way to fix any problem like that is to just divide everything by a -1, because now negative divided by negative is positive. Positive divided by negative is negative. Correct. The only thing that can't be negative is what they call the a value, the number that's in front of x. Once x and y are on the same side, and that's positive, this is what we call standard form. These all have benefits for us at one time or another. If we're wanting to do a quick graph by intercept, standard form is the best. If we know the slope and the y-intercept, slope-intercept is the best. If we're doing applications, point slope tends to be the best. So we're using different tools for different things. Now, am I going to ask you on most problems to do all three like we just did there? No. There will be some. But this is mainly to start getting used to the differences we can use. So, to get an idea right away of how we can use this, we're going to do an application problem with this right off the bat. You're like, oh my gosh, throw us in, Hardy. Let's do this. A construction company charges $15 per hour for debris removal plus an initial fee for the use of the dumpster. The total fee for 9 hours of service is $195. Write the point slope form of an equation to find the total fee for any number of hours. Like Hardy, there is Y, there is X, there's numbers. How the heck am I going to figure this out? Okay, let's break this down. I'm going to tell you each time you see a problem like this exactly what each thing is going to be. Because that way, when you see it again in the future, you're going to know where to go right away. So here we go. Whatever your rate is, okay, whatever something is per hour, per job, per whatever it is, that is going to be your slope every time. Because if you think about it, $15 every hour. Every 1 hour, it goes up 15. Over 1 hour, up 15. It's going to be your slope. How much is it going up each time? So that won't change. Then I read a little further. Okay, the total fee for 9 hours when you get your time, that's going to be your x1 in your point slope form. Time will be your x value. The total fee for 9 hours, x1, of service is $195. That's going to be your y1. Okay? Time is x. Value is y. That's why we're going to have this on here like this, so you always have it as a reference point. And so what we're going to be looking for, well, let's get it into the equation. I'm getting a little too far ahead of myself. So let's kind of start from the very beginning. Okay, write the point slope form. Okay, here's the generic point slope that we got up above. And just like we said before, we're going to be plugging in for y1, for m, and for x1. The plane y and the plane x just stay plane y and x. We don't mess with them. And if I've labeled my stuff, which is a good idea, okay, y1 is 195. My m is my $15 per hour. You're like, wait a minute, every other time we've said per, that's been x. The x is included there for us, so we don't need enough extra one. Minus 9 hours of service, my x1. So you notice I'm color coordinating, I'm making sure things are getting plugged into spots. So if I was asked for the point slope form, okay, again, if that was the whole thing, I'd be done. But it's not this time. We're supposed to find the total fee for any number of hours. What was the initial fee? Okay. My next job is to get this in to slope-intercept form. And then you're going to see why this needs to be. What's that? We're always going to start in point slope and we're going to end in slope-intercept. And when we get there, I'll show you why we've got to end up there. And we'll label it too, so make sure that we're there. So my first job, we got to get rid of the parentheses. We're going to distribute the 15. We're going to multiply it. Again, calculators are not bad things. So if I want to get into slope-intercept, I want to get y alone. Need y alone. I need to do the opposite of that, minus 195. And we're about done already. You're like, okay, so how did getting into slope-intercept form help me? Here's why. When you get to the end, what was the initial fee? Okay, here's the insider info. The initial fee is the y-intercept of your equation. Wherever your equation crosses the y-axis is what you started with, what you were charged before anything started. When I'm in slope-intercept form, there's my y-intercept. That's the initial fee. This has turned into a very weird way of equation solving. Except we're allowed to use this initial equation and just transform it to take a piece of what we need and get the answer. Very crazy at the start, which again is why we give you an outline like this and let you keep using it right through the practice and the quizzes. But you got to have this to be able to make that happen for you. So again, not a terrible thing. Keep it handy. It will come in useful. So, as we start to get ready now to head to the practice part, because we always got to do the practice. That's the only way we reinforce this, and it gets better. If the only time you see it is me saying it, the likelihood of it sticking is not real high. So, let me tuck that up for a minute. We're on page 1, but our practice today actually is going to be on page 1 and 2. Not while I'm in the middle of the lesson, no. When we're done, we can get started. So, what's that? Oh, the page number got cut off. What the heck? Okay. So as we get started, you're going to want to pay close attention to the directions because the forms are going to change a bit as we go. Write an equation in point-slope form. Okay, there it is. For the equation that passes through the 2 points. So reminder, x1 and y1 and m. Those 3 things are all I have to plug in for. So all I'm going to do on number 1, keep it simple, don't do too much. Y minus y1, which is 5, equals m, negative 1, x minus negative 2. But what happens when you minus negative 2? When you minus a negative, if you were going to look at Hardy's answer key later, if you were checking something, you'd notice minus a negative makes it plus. So the question I then assume would be, well, if this was a quiz and I put that, are you going to take it? And the answer is kind of. I would probably put a little reminder in there for you and ding like a half point instead of a full. But if you minus a negative, we got to know what that's plus. Because when you go to graph something, you wouldn't want to look at it that way. But that's it. Plug them in, you're done. So nothing too bad there. At least I hope not. Now the next ones, they're already in point-slope form. But we want them in slope-intercept. So, if I need assistance on that, let's kind of fold this up a little bit. And I go, okay, so basically we distributed to get to here, then we minus that. Okay, so we distribute. Negative times negative is positive. Got to be looking for the details. And I need y by itself. Do your opposite, minusing 6. And again, numbers stay with numbers. Don't try to add that 6 to the 2x. That's not going to work out well. Not going to work out well. Trying to get y by itself. And stop, because that's all I'm being asked for. Keep life simple. The last one then, now this one gets a little more interesting. I'll even do the one that looks crazy with you, because that could be a little wild. Let's do number 9. You're like, ooh, it's a fraction. Yuck. Okay. To get to standard form, we got to be rid of the parentheses. So let's do that first. Do not be scared off by the fractions. What's half of 4? 2. So we're going along like, okay, let's get this y alone. Let's get the 4 out of there. You're like, we're rolling. Now, we have a slight problem. When we're going to standard form, reminder, x and y both have to be on the left side. Okay. I can do that. We're going to move the x over. If some of you write big, I apologize, because this is going to get a little tight here, but we'll figure it out. We may have to get creative here. Now, the first part of the job is done. Because remember, x and y have to be on the same side. Okay, they are. They're both on the left side. That's good. The x term must be positive, oh, and not a fraction, oh. So here's how we fix that if that happens. You're like, the last time we divided, but this time I have a fraction, so what do? Here's what we're going to do. We're going to multiply through by a negative. And we're going to deal with the fraction at the same time. Whatever this number on the bottom is, we're going to multiply by it. So check this out. If I multiply through by -2, negative times negative is positive. 2 times a half is 1. So 1x. Check. -2 times positive 1y would be -2y. You're like, wait a minute, Hardy, that's negative. It is, but remember, we only care about the x being positive. Y can be negative. That's okay. And 2 times -2 is +4. That is the craziest these problems can get. Most of the time, you're not going to have that concern. You might have a negative, you might have a fraction, but it's not going to be double. So that's just something to consider. So when you're doing these, again, once you get it into y equals, just get the x to the left, and if you've got to deal with the negative, we multiply by a negative. We got a fraction, we just multiply by whatever the fraction number is, and we'll get there. So that one was crazy, I'll admit it, but it still wasn't too wild. Graph each line given the point and slope. Okay. Let's see. Oh, my graph got cut off. Okay, we're going to get creative, people. We're going to get creative. 1, -6. I got to go a little lower than the graph gave me here. And my slope is -1, or -1/1. So normally I'd go down 1 and right 1. So again, we're going to get creative. Down 1, right 1. I don't know why I put a point that wasn't even on the graph. That's kind of silly. But we made it work, luckily. So sometimes we got to just do what we got to do. But plot that point, and then you're going slope from the point, just like we had in the notes. So like, all right, it's terrible so far. As long as Hardy doesn't do anything crazy. All right, one last one, because I want to run through another one of these applications with you, where we got an example to work with. Okay, let's do this. An internet provider charges $18 per month. Here's my slope. For debris removal, plus an initial setup fee. One customer paid a total of $81. Be careful. The total number is your Y. That is your Y1 for 2 months of service. There's my X1. So again, time is X, quantity or cost is Y. That's the one thing I got to keep straight. So write the equation in point slope form, modeling this. Okay. Let's start plugging numbers in. Y minus Y1, which is 81, equals M X minus X1. I'm literally just plugging numbers into those 3 spots, the same 3 spots that I labeled right here. Okay, that's your equation in point slope form. So letter A, good. What's the initial setup fee? Oh, I got to get it into slope-intercept and look at my B. Okay. Same thing we did here. Notice how I'm just basically copying every step that I did in the example. That's why we've got it there. Until I'm feeling comfortable, I'm just going to keep following this. And I'm like, okay, now what? Oh, I got to get Y alone. Once you're in Y equals, once you're in slope-intercept form, you have the setup fee. It's $45. Whatever that number on the end is, whatever your y-intercept is, will be the value that you have. But this time they had one more question, and we didn't have this in the example, so we better focus in here. How much does it cost after 5 months of service? The M is per month. So this just says, substitute 5 in for X. So I'm going to take my equation. And when I get to X, I'm going to plug a 5 in there. And I can punch that part right into my calculator. 18 times 5 plus 45. And get my answer. Okay, there is nothing else on this sheet that you don't have an example for. Try to set up with the example. If it doesn't work perfect, again, check the answer. If it still's not working, talk to me, ask me, email me, pop in on me. Any of those things are fine. But keep making the efforts forward to improve it just a little bit every day. So your job's to knock off the rest of this practice on page 1 and 2 with the examples and the ones we did on here. And then tomorrow we'll expand a little, just a little, as we keep moving forward.